Okay, good evening, everyone. And this is, I think, the last training on the data analysis on water quality. And we are going to start with some introduction, and then we discuss about selected parameters of concern, and then we have data analysis and graph, and then we have interpretations and discussions. So next slide, I'm going to start the slideshow. Okay. So we will talk about descriptive analysis and correlation analysis, and then graphs, and then interpretation, and then discussion. And then we have parameters of concern, which is pH, temperature, nitrate, arsenic, E. coli, fecal coliform, enterococci, and then we have fecal streptococci, and then we have chloride, dissolved oxygen. So normally for analysis, we cannot use just one result, or maybe we just want to compare the result with one standards. So we are using two standards. We are using the standard of the country and the WHO standards. With our results, then we are able to produce our graphs using this result, because we already saw the results and the values for the different parameters in the US and in UK. So today we are going to practice more in the UK data, which we treated yesterday, and then the other data, you're going to use it for your own practice. That is data for US, following what I'm going to show in this presentation. So this is for US. If you need, for example, you want to get the quality guidelines for US, this is the link. So if you click this link, it's going to direct you to the portal where you have the water quality guidelines for United States of America. And you'll see the different parameters and their guidelines. And this is a table which represents what we are going to be checking or looking for, the different parameters and their guidelines. So you have USWG, so which means US water guidelines, and then WHO guidelines. So for pH, we have the results which we got from Maryland, and from our data which we filtered. These were the results, 5.8. And then according to US, actually pH does not have a particular guideline, because sometimes it's just about some range in between 6.5 to 8.5. So, but US states that this parameter needs to be at least 9.5, like that is not exceed 9.5. And so we choose 9.5 as the best value for our data. And then we have WHO, which is from 6.5 to 8.5. So we choose the last value, 8.5. And then for temperature does not have a particular set value, but normally, you cannot drink too much hot water if it's just maybe water for you to drink on daily basis. So on average, we just use the general standards, which is normally acceptable, which we know in a general format, not being based on US or not being based on WHO. So we use 22 degrees here, just for the purpose of analysis. And then this is the temperature for the water source in Maryland. E. coli is 150 colonies per 100 mils. And we are going to see some of these things when we start looking at the data again. So, but according to US guidelines, there needs to be 0 value for E. coli, and WHO the same, 0. And we have fecal coliform, it needs to be 0, 0. and 0, you see. And then for nitrates, it's 45 and it's 50. Yeah, the results were 1.31. And then dissolved oxygen, we have 4 and 5. Now, this 5, actually, there's not also a guideline for dissolved oxygen in both US and generally in the WHO water guideline book, which we have. So for UK, to be able to get the water quality standards, you can use this the link. This is the website to be able to access the UK drinking water standards and regulation. And we can check also. So these are the parameters which we can be considering as of concern, which we will be able to do our analysis and come out with some interpretations about the water quality in UK based on our past lessons. So these are the various results we got from our data. And then this is the standards, which I already explained in the previous slides. Okay. So now I think we should move on to get to practice now. And let's see how I'm going to start sharing my screen in Excel, and then we'll be able to start doing the practice. Can you see my screen? Maybe.
Yes, I can see.
Okay. So this was the data which we got, I think, yesterday. I think, yes, arsenic. Yeah, we found arsenic. I think this is the data. So, so if we look at this data, we are able to see here this value, determinant units level, that is microgram, milligram, microgram, you see. So these values, we must be careful when we want to start doing analysis, and we must know if we are able to convert or not. So for example, just for practice purpose, and what we need to do now is to be able to generate our own data or parameter of concern, which we saw in the slides. And we already copied these values which we need. And we see these are the different values. So now we can now decide to maybe highlight the particular parameters we need. So we can say we want this. We go to home and then we highlight it. Okay. That is temperature, and we have this of oxygen. Like I said, these are parameters we need, which are of concern. We go down. This is because we want it to be more easy, so we can be able to understand what we are doing. pH, okay, and then we choose so we go down. Okay, we need this confirmed, EI confirmed, yeah, antioxidant. We need ion, yes. So this is what we are looking for. Okay, we need nitrates and these. Okay. So this is how we want. Okay, we need We need chloride. Okay. Okay, so I think this is what we also need. Maybe we need sodium, I think. So yeah, this is for our analysis, and so it's now going to be easy for us to like, so if we want, we can now choose which particular column we want. Okay, these are the results, and you can change this to results of Howberry pack cover. Okay, and then here, this is the definition, and we need this, so we can say water parameters. Okay, so we can now decide if we want to delete this. So that we all know about the different signatures. So we can now go ahead, and if we want to delete, then we can delete this before we select our values what we want. So we can delete this, delete. Okay, so we have now this table. It's now really good before our eyes. What we do next, we would like to filter the data. And now we have to now select what we are seeing. So we need to select temperature, oxygen dissolved, pH. Okay, so how do we do that? So we come, this is the select all. So we have to select this, and then we select our particular parameters of concern, and we go down, and then we're checking. So we had chloride ions, yeah. We are going down. So this is E. coli. This is, yes. This is enterococci, yeah. And then we need to check. This is iron. This leads. Okay. So this is nitrates. And whereas I think we should select nitrites too. So it's going to be good analysis. Oxygen dissolved. And there we have pH. Let's see what we are going to have here. Sodium. Okay. And okay, temperature of water if we need. That's okay. Okay, so this is what we have as our final results of test, water quality test. And so we have temperature of water, oxygen dissolved, and this, and this. So now we want to go to analyze this data. And so we need to copy this and move to another sheet. So we create a new sheet. Then we're going to copy this, copy, and then come here and paste. Paste. If we realize this stuff, we have to do like this, and then so everything should be equally spread. Okay, so yeah, so okay, so this is what we have. We can also decide to make this bold, and then we highlight all of these, and then we say no field. Okay. So now in this column, we are going to put UK water standards, and then we have WHO. Okay. So what do we do next? Since we have our values, we know that for countries, we talk about standards, and for WHO, we normally mentioned guidelines. And so these values I showed in the presentation. And so let's just go for temperature of water. Remember, we said we are going to use 22 because it's fair enough. And then dissolved oxygen, we said we are going to use 5. And when we start discussing about the analysis part, I'll explain more about this part. For pH, we said we are going to use 9.5, and then we are going to use 8.5. WHO, and then for E. coli, it's 0. Yeah, you must have 0, 0. And then sodium, for sodium, we have 200, and then 200. That is for sodium. And then for enterococci, according to UK water standards, it's supposed to be 0. Yeah, it's a standard. And then iron. For iron, we are going to have, I think the standard is 200 here, and then we have 300. Okay. And then we have for nitrate, it's 50 and 50. And then for lead, we have 10 and 10. Okay. And then we have for nitrates, we have 0.5. And then we are going to have 3. Yeah, we have 3. And then for chloride, we have 250 and 250. Okay, this is fair enough. And I forgot to include one parameter which is very important. Arsenic, yeah, arsenic, which we must include, very, very important. So arsenic filtered is 1. So we might want to copy this like that, copy. Okay, and then we can paste here like that, and then we also put no field, and we have that. And then we have for arsenic, we also have 10 and 10. So the most important thing about this data is that before we start analysis to produce and to bring out conclusions about this particular water source in UK, we must make sure that the units of measurement are the same. For example, if we have, like, I can take the case for arsenic. Arsenic is measured in micrograms per liter. And then we also have the standards also give the same measurement unit. So it must be the same. Like, for example, this 10 is also microgram per liter, and WHO is also showing microgram per liter, not to be confused. So you can you can try to maybe convert these values, but if you have the same, it is what we need. So you must have the same unit, like I said. So if it's milligram, for example, chloride ions, yeah, it's in milligram per liter. And so this also for the national standard also needs to be in milligram. And also WHO value needs to be in milligram per liter. So we don't need to have, for example, in these measurements where we did our water test and we get some results and it's showing the values are reported in microgram per liter, and then we want to do our analysis, and then we are having at the other point, it's in milligram. So you won't be able to have a good analysis at the end of the day. So we must make sure that the unit of measurements for this coincides with the unit of measurements for this and this. It must be the same. So if it's milligram, if it's milligram here, it should be milligram here, it should be milligram here. If it's microgram, it should be microgram here, microgram and microgram. So that said, we can also decide to pick this board. And so we can have a good view of this data. Now, what do we need to do? We have to bring in our data analysis tool pack to start doing our analysis. We will start first with the descriptive statistics of our Howberry paragraph results, and then we'll be able to do correlation analysis. So how do we get our data analysis tool pack in Excel? So it's very easy. You go to File, and then you come to Options, and then you go to Add-ins, and then you will see Analysis Tool Pack. You click on it, and then you come down, and then you click on Go, and then you select it. Select this box, Analysis Tool Pack box, and then you click OK. And so it'll be easy. And when you want to do your data analysis now, you can go to the data, select data, and then you have here data analysis. So let's start with the first analysis, which is the descriptive statistics for this Howberry pack. So we click on data analysis, and then we are going to have descriptive statistics. We click on it, and we click OK. So what then do we have to do? We have input range. Our input range is the value which we want to do our statistics from. And so we are going to click that, and then we delete, and then we have like this, and we have to select all of this, and then we click on this, our labels in first row. Yeah, so we have labels first row, which is this, and then we leave this. So our output range, where do we want these statistics to be displayed? So we are going to click on this, and we're going to select where we want that to be. Maybe let's say here. Let's click on that, and you see it has been highlighted. Doesn't matter. And then we click on summary statistics, and then we click on OK. So it's now here, and we can see what we have. The result is here. So this is the statistics. So we have the mean of our data. It's 17.5. We have the median, 3.35. We have the mode, 1. So minimum and maximum. So the maximum value of our data, of our measurement is 110. And then we have the minimum 0.004. So now, this is just about the descriptive analysis. We can go further ahead to do correlation, which is the key points in our conclusions, in our visualizations, in what we need to assume and what we need to say about this water source. So we can click on data analysis, and then we click on correlation, and then we click on OK. And so same thing, input range. We want some input range. So we are going to be correlating the Howberry pack results, water quality test results, with that of the standards of UK and WHO guideline. Please follow. And we have this. We click on that. And we say, okay, same thing, labels in first row. And then output data, we want it to display. Where do we want that to display? Maybe you can click on that and we go up. And we want it to be displayed here. We click back. And then we click on OK. Okay, this is great. So we now have a correlation analysis between our results and that of UK water standard and WHO. So hope you guys are following. Okay, now what is the correlation all about? Is to give us an idea. Correlation is just about giving us an idea where we can be able to see how true our value is and what we can accept at the end of the day for our analysis. And correlation, the statistic or the analysis for correlation ranges between -1 and 1. So if your value is if you're going to correlate between two different data, then if you have a value which is closer to 1, it means that it has a positive correlation. And if you have a value which is closer to -1, it means that it has a negative correlation with that. So let's look at it. So for result of Howberry, we have 1 to 1. Howberry to Howberry correlation is 1 because actually this is same data. But now the point of this correlation analysis is to be able to correlate our Howberry data with that of UK and WHO. Okay, so these are standards. Remember, this is not a test that was conducted for any water source. These are just standards, which means these standards just tell us that these are red lines or this value should not be crossed. When you have a data and you have, for example, your test result and it's above this value, it is red mark. Okay, so this is not a test result from somewhere. So these are just points which was highlighted and recommended that if you're testing, your value should be at this range. So we call them red marks. Okay, so it doesn't mean it's their test. Okay, so what we want to do now is to be able, these are real values, these are tests, okay, which was conducted for this particular water source. Remember, the water source we are dealing with right now is a borehole in Howberry Park Gravel. Remember, if you watch the previous video. So now, how do we understand? In water data analysis is just kind of very, very kind of opposite. We don't talk about positive now, or if we are having positive, it means the water source is good. No. So for example, if we take Howberry and correlate it with that of UK water standard, what do we understand from here? We understand that this is 0.7. This value is positive, is closer to 1, but it's a risk if we are analyzing this, because we understand that if it's closer to 1, it means that it's the value or the test results here. For example, let me say we have here, look at this. This is iron. Iron is 110. This is the test result. And the standard is 200 for UK. It means that this contaminant in water is actually very close to the red mark, which is not a good thing. So that is why if we are having a positive a correlation, which is closer to 1, it means that this water source is not okay. that is the first analysis you must be thinking using the correlation data analysis method. So we have here WHO, we see the 0.8. Also, it is positive, very close to 1. But we have to make sure that we are understanding why we are doing this thing. For example, it's closer to 1, and it means that the values or the test result in general for Howberry Howberry Park gravel, it's not actually a good sign. That is, there is no the correlation is not good, and the water source might have some issues, because it means that the value of the test results are always, or they are almost closer to the red line. That is the standard, as I said, red line. That is, you should not cross. Like, for example, we have 7.4, look at, we have 9, and then we have some other values which are very close. And at the end of the day, if we discover that we are seeing this kind of correlation, then it means that the water quality of Howberry Park gravel doesn't make sense. So the possible values which we must consider if we have an analysis and we see that it's better for your values, your recorded results or your test results, to have a more lower value. Yeah, you should have a lower value compared to that of the standards. It should be very low. For example, if we have, for example, iron, we say iron should be maybe 2, and then we have 200, 300, then it's good. It means this water is really good. It has a very good water quality, and then we can be able to analyze. So what then do we do with this? So we are saying that at the end of the day, it is good. A water source can have a good quality when the correlation between the national standards and that of WHO is between the range of 0.3 and 0.5. Then we can be sure that, oh, this particular water source is, fairly good, because the values are far away from 1. Okay, so the values are far away from 1. So that is what we need to do, and we understand about the correlation method. So what we are going to be doing now is that if we see UK, we see is 1, and we see UK WHO 0.9. It doesn't mean that UK and WHO, maybe UK and WHO don't have some kind of relation, which is maybe the relationship is negative. No, because remember I said these values are just standard values, which they are not recorded test results. Okay, so this is the true value. This is the real value. Okay, the graph is very easy. I don't want to complicate our lives, so what I'm going to do is that I can highlight like this, and then let's see how our graph is going to be like. Let's try to check this and see. Okay, so this is what we have. Wow, so beautiful. And this is correlation, and this is the graph. A very nice graph. So this, we can see the trend, how the water quality changes. And we have here, this is the result of Howberry in blue, and we see where it coincides. It shows that it meets the standard of WHO or UK. Okay, so you see when it comes down, it's lower than the set guideline for WHO and UK. You see, so this is a very good representation, and the main basis is just about how we could correlate it. So that is how it is, and we have here on our down table, we have the temperature of water, we have oxygen dissolved, We have pH and this, you see, everything is good and the graph is okay. And let's see what to do next. So with these statistics, you can as well go ahead to produce your title. You can go ahead and produce your title. And then we can have the description. So now, how can we analyze this water quality? Remember that E. coli is one of the most dangerous indicator. We can say it's an indicator, and it comes out to mean that these are pathogens which are found in our water source. And so it is very important for us, no matter how good our correlation analysis might be for us, maybe 0.3 or 0.5, yes, but we must check the important indicators and which are the fecal contaminations. And we have here E. coli, and we have here Enterococci. It is 1, and it is strictly prohibited, and it must be 0. There should be no trace of E. coli. And we know this is what always we have as issue with waterborne diseases. So when we are analyzing, according to our results now, we already see that the borehole water in Howberry is actually not good, okay, from our correlation analysis alone. Now we are diving down into interpreting and going into further analysis to understand what we are having. For example, now we are seeing that we have E. coli, which is 1, and this is 1. So it means that the community or the people living in Howberry, what then should we be saying? Because we are having a contamination. Maybe probably this water, like we were saying, is being consumed or being used for other domestic purpose, okay? Automatically, what do we need to do? We need to understand that the people in this community are at risk of being infected with waterborne diseases such as cholera, and diarrheal diseases. And also we can talk about typhoid fever and the rest. So we must understand that this is the concept of our analysis. We have to understand that these values are very important. And we can also brief to understand our facts. And that of nitrate, we also know about nitrates. And if the value is high, and I think fortunately it's not high, so we see that it's 2.6, okay? So it is kind of fair enough. And because if we have high values of nitrate, it means that newborn babies which we have come in contact with this water, maybe by consuming, might develop what we call the blue baby syndrome, okay? And also leads is also very dangerous, and if we have it in our water system. So fortunately, the value is 2, and the standard here is 10, okay? And then we also have arsenic. Arsenic is also very not good. So some of these diseases are caused by arsenic, it's arsenicosis. So if we have some value, like I said, what we are trying to analyze now is to come out with a positive understanding. For example, for arsenic, if the value is maybe 6, I can say, if we have 6 for the value here, it means that, well, some persons might be of greater health risks, but yet, remember, it has not yet reached the error mark or the red line, which was said. So every human or every individual have their own immune system, okay? So we must try by all possible means. When we are analyzing, we should be fair enough to understand that these things are really needed to be clear to the community or personnel which want to present our results the way we want to discuss, okay? So if we have 6, somebody might consume a water source, for example, this Howberry, and has maybe the Howberry has an arsenic value or level of 6, and that person gets sick, while some other person might consume this water and not get sick. So in all we want to do is to make sure that when we are reading and we're seeing our values, it should be fair enough that the values are really below what might cause some health problems in the community. Same as here, for example, the iron level is 110 and we have 200, which is said. So this is already closer to 200. So tell me, some person might be able to consume this water source and of Howberry Park, and the person is not sick. Another person will consume, the person will be sick. So in all the same, we should have our analysis at the end of the day and say that this is good, this is not good, this is good, this is not good, okay? And if we are checking on the aspect of dissolved oxygen, it's also another important factor. So if we are looking at dissolved oxygen in this result, we discover that it is 4.1. It is fairly good. And if we are saying dissolved oxygen value of 5 or greater than 5, where is good value, because we have a lot of it helps water taste good, okay? So, but at the same time, it facilitates the corrosion of water distribution pipes, okay? So if we have higher values of dissolved oxygen, it facilitates the corrosion of water distribution pipes. So it should be fair enough. But if the oxygen, dissolved oxygen is really low, less than 5 or less than not less than 5, less than 4, less than 2, less than 1, then it is a problem, especially when we come to aquatic life and like organisms in the sea, you know, and we can have a lot of low dissolved oxygen. Therefore, the organism in the sea or in the ocean, they are going to stress too much because they need this dissolved oxygen also to breathe, like that of fish, you understand, fish in the water. So it actually uses dissolved oxygen to be able to get that. So, but remember, we are doing an analysis for groundwater, which probably is not in the sea. So before you are bringing up analysis, you should know where the water source is and what it entails. This water source is meant for community purpose, for consumption, or to carry out domestic purpose. So we are not too much, the oxygen dissolved, it will not be a big problem because we are humans, you know, we're taking oxygen through our nostrils. Okay, we are not fish or, you know, some water bodies organism or some water organism. So we are now understanding that our data at the end of the day, it's more very, very feasible. And we see that in conclusion, the Howberry Park gravel borehole water doesn't meet neither the standards of WHO nor neither the standards of UK. So at the end of the day, it is contaminated. And so what recommendations do we give? So the first recommendation is that in this area, they need to provide a means of treatment of this particular borehole and to be able to provide disinfection, okay? And also provide a means. If that is not possible, then the community should go ahead and then find a way to stop using this water source. So they should put a restriction, because we know these are the most terrible things that will happen if we have E. coli and the rest as pathogens found in our water, cause a lot of problems, a lot of deaths all around the world. We all know about this. So according to our analysis as water quality experts and as leaders, as you guys have been trained through this program, you understand that this is what we should have as a conclusion, because we are seeing high level of risks which are found here, okay? Have high level of risks which are found here, okay? See? And so we might be talking of a lot of things. So these are the risks which is very, 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 very important for us to identify. And also we have our general conclusion. So at the end of the day, it doesn't meet that of UK water standards, nor not that of the WHO guidelines. So this water source needs to be followed up and checked to see how to help the community in UK. So guys, I think this is this for our analysis. And I already explained this, how you can understand how the trend moves. You can now understand how we are going to do. So but I think we have our group chats, remember, and I'm going to pass out the information. If you have any questions about the video, since there's no time, please, you can write in the group chat, and I'll be able to answer your questions, and we can now see how to move forward. And I wish you all good night. And I think I'm going to include the other video for the analysis in US, and we are going to also see how the US water system is going to look like. Okay, so thank you, and good night.